Welcome to LabMinutes.com and our lab video series in BGP. You can find your playlist of BGP video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. So in our last video, we looked at how to build a scalable BGP topology using a route reflector. So in this video, we're going to look at our second option, which is Bgp Confederation. And we're going to look at Confederation from the perspective of iBGP and eBGP, and we're also going to look at how the BGP attributes like local preference, MET, and community, specifically local AS, are treated within the BGP Confederation. And just like the route reflector, like I mentioned in the last video, the key to understand the BGP Confederation is lying under the rules of route advertisement, and also to understand how the default iBGP rule has been changed or kind of relaxed to allow you to build almost arbitrary BGP topology. For a physical lab topology, we have 7 routers, R1 through R7s, with R3, R4, and R6 having a full mesh point-to-point serial link interconnects between them, as well as R1, R2, and R5 having a point-to-point serial link connected between them. And then these two groups of routers are interconnect over VLAN 123. And on the right-hand side, we also have a VLAN 27 that connects R2 to R7. Now, moving down to see our layer 3 topology. And the way that we have the routers grouped into confederations looks very similar to what we have in the previous lab videos, but instead of these being a autonomous system, it's what they call a sub-autonomous system with their own confederation ID assigned. And this is just to pretty much show you that you can design your confederation topology in pretty much any way you like, and you have almost the same freedom as when you were to design an eBGP, with one of the main exceptions being that all these routers are still sharing the same internal routing protocol. In this case, we have chosen ISIS with a flat level 2. So you can see that each of these has a net ID for ISIS that is part of a area 0, 100. And each of these routers also have their loopback 0 advertised, so any of these routers can reach each other's loopback 0 IPs. So as a whole, these routers are still operating under the same AS number, AS100. Also, I will be using the term confederation interchangeably with the sub-autonomous system throughout this video, so there might be times when I use confederation to refer the sub-AS. So let's begin now configuration with our task number 1, confederation with iBGP. So we need to configure iBGP session amongst router R1 through R6, and we're going to have to partition them into a different confederation with confederation ID 65001 for R1, 2, and 5, 65002 for R3 and R6, and then 65003 for R4. And then within the confederation 65001, we're going to build a full mesh iBGP between R1, R2, and R5 using pure template, and then we have to build these iBGPs between these sets of routers. And out of the sessions, we're going to source our BGP from loopback 0, and then also advertise their loopback 10 through 12. Okay, just to go back to our diagram, so basically what we're going to be configuring is this topology right here in the middle. So if you are following along with our video, you might want to print out this page right here so you can use it as a reference as we perform our configuration. Okay, so first we're going to take care of these 3 routers at the bottom, R1, R2, and R5, and we're going to use the pure template for our configuration. So let's first hop on to our router R1 with the command router BGP, but instead of typing in AS100, we're going to have to enter the sub-autonomous system number. In this case is the 65001. Then do no synchronize and no auto summary, and then give it auto router ID, BGP router ID. 1601, which is the loopback 0 of R1. And then we're going to have to define confederation identifier as far as we need to let this particular router knows what autonomous system number is actually operating under, and that would be our AS100. So the command for that is BGP confederation. You can see we only have 2 options, and one of those is identifier. And for us, we're operating under AS100, and this is what's the external BGP peers will be seeing us as, which is AS100. And don't get this confederation identifier value confused with what we have to find right here. So maybe a better term for these should be a sub-autonomous system number rather than a confed ID. Okay, and then after that, we need to also define a confederation peer. So as far as we have to let the router know what's the confederation AS number that the router will be peering with. So in the case of R1, that would be a confederation of 65002. So that way it knows exactly if the peer is part of the whole confederation structures or not. And obviously if something that's not listed in this list, that means it's just another eBGP peer. So for R1, we need to let the router know 65002. Okay, and then we can go ahead and do our peer template with template peer session. I'm just going to call it CID 65001. And this is for our BGP session within our confederation. Remote AS is going to be 65001. And then we need the update source from loopback 0. Okay, then we need to add two neighbors. One is our router R2, inherit peer session CID 65001. If you guys are not familiar with the whole concept of using peer template, then we have a separate video that you guys can reference. But it's just the way to save time and your configuration when you find yourself having to repeat your configuration, just like how we're doing right here with the iBGP. Okay, now we just did R2. Now we also do R5. Okay, since R2 and R5 are sharing common peer session information. And R1 also has a iBGP connection to R3, so we're going to have to define R3 as our neighbor using a source loopback 0. So 65002 for R3, and then we have to do update source loopback 0. Okay, so just one quick note I want to make. When you build a connection that crossed the confederation, that particular session right here is going to be treated almost like an eBGP with regards that the BGP packet's going to be set with TTL value of 1. So if you remember when you built a eBGP session across multiple hops, by default that would not work because the TTL will expire before the packet reaches destination. So the same will apply here. So our options would be whether either we can use the eBGP multi-hop commands, but again, we have a separate videos that we have already talked about the difference between using eBGP multi-hops and the TTL security command. We prefer to use TTL security, so in our configuration here, we're going to use a TTL security that's going to allow R1 to R3 to peer using their loopback interfaces. So we're going to do the config of TTL security, and then we have to define the hop count. In this case, since we're just doing directly connected peers with loopback to loopback, all we need is hop count of 2. Okay, just keep in mind that since we're also dealing with IGP, or IGP is actually being used to provide reachability between the loopbacks, and that will give us redundancy. If the directly connected link between R1 and R3 goes down, then those two routers can just reroute the packet around it from loopback to loopback. But just keep in mind that when that happens, TTL of 2 in this case might not be enough, so you make sure that if you want to allow this packet to be rerouted, you set the TTL value to withstand enough hop counts. Okay, but for us, we're just going to make it 2 in this case, and not even to allow reroutes for the loopback. Then we need to advertise R1 loopback 10 through 12. So it'll be 1100 0, and then 1110 and 1120. Okay, so let me do a show command of that and kind of save ourselves some configuration. I'm going to bring up a notepad and then copy all these. Since the configuration on R2 and R5, it's going to be almost identical. So for R2, we need our peer template. That's fine. Then we're going to need our router ID of 2. These are the default. Confederation Identifier is going to be the same, AS100. Confederation peer, for R2, it's going to be peering with the number 65003, so that has to be changed to 3. And then network is 22 on all of those. Okay, and the neighbor is going to be R1 and R5. And then for crossing the confederation is going to be R4. Okay, and the remote AS of R4 should be 65003. Okay, so let me copy that and then get onto R2 and paste right there. See, make sure there's no errors. I can see that the BGP session to R1 is already up. So next we're gonna be configuring R5. Just gonna use the same template that we have right here for R5. The router ID is 0.5. R5 doesn't really peer directly to the other confederation. So let me delete that. And then network is 5.5. Right, and R5 peer is R2 and R1. Okay, so we can delete that. Let me copy. And then on R5, paste. Okay, give it a second. The BGP session should come up. Okay, there you go. Session to R1. And we've learned 3 routes already. Let's make sure I can ping. There you go. Session to R2. This came up as well. There you go. We also learned 3 routes. Okay, we do show iBGP. You can see we have R1 loopbacks and R2 loopbacks. And also it's on loopbacks. Okay, so we are done with this Confed ID 65001. Next we're going to move on to the 65002, starting with router R3. But since we have a template right here, let's leverage this. So router BGP 65002. We have no sync, no auto summary right here. Router IDs should be 3. And we're not really using a peer template on R3. Bgp Confederation Identifier is 100. We also need a Confederation peer. And for R3, since R3 going to be peering 65001 and 65003, so I have to identify or define those. 003. Network is 3.300, 3310, 3320. Okay, then we need all the neighbor commands. So let's start off with 1601. So that's a session to 1 with the remote AS 65001. And then we need the update source, loopback 0. And then since we're crossing confederation, we're doing loopback to loopback. Don't forget the TTL security hop of 2. Okay, so let's copy those in first, and then we'll come back and finish off the other peer. Just make sure we don't have any syntax error. And we don't. So now we need to configure the session to R4 and R6. So let me copy that section. Neighbor, this time is R4. So all these should be R4. And then the only change we have to make is the remote AS to 65003. And then to R6. And that would be 65002. Okay, and since it's within the same confederation, I don't need the TTL security. So let me copy and paste this. Okay, so BGP session to R1 is already up. And we can do show IP BGP before we move on. So as we learn all these routes from R1. We'll come back and review this BGP tables later. Right now I just want to get the neighbor to come up. So next will be R6. R6 is still 65002. Router ID will be 0.6. And R6 is only peering with Confederation 65003. So we don't need the 65001. And then we have 660, 661, and then 662. Okay, and instead of R1, we're going to change that to R3. And we don't need the TTL security. And then R6 also have to peer with R4, so those should be identical. Okay, so let's copy this. Go over to R6. Okay, so far so good. And the last router that we have to configure is R4. So we're waiting for the session from between R6 to R4 and R3 to come up. Let's go ahead and configure R4. Actually, session to R4 wouldn't come up since we haven't really configured that. So 65003 for R4. BGP router ID is 4 and identifies to 100. The confederation peer, since R4 is peering with 65002 and 65001. So that would be 1, that would be 002, and 4.4. As you can see, that a lot of these configurations are very similar. That's why I'm working on a notepad, and that way it's actually just a minor modification. Then we just copy and paste. Okay, so first our 4 goes to R2. So let me copy that. R2 to 65001. So we got that, and then you got R3. But since we're crossing the Confederation, that would have to be TTL security set to 2, and then that would be R6. Make sure that's we get the right sub AS number, and that should be it for 4. So we hop over to R4 and then paste. Okay, I'm not sure why the session from R6 to R3 is not up yet. Looks like I have an incorrect config right here. That should have been 65002 for R3. So let me kind of remove that from R6 and then change that to 2. Okay, that should fix it, and that's why the session to R3 wouldn't come up. Okay, give it a second. There you go. We got our BGP session coming up. So now let's go through our routers and make sure that we have all the session that we expect. Starting off with R1, we got our 3 sessions. R2. Okay, so R4 hasn't quite advertised anything yet. Let's jump over to R4. It should be now, I believe. Do show IP BGP on R2. Looks like it's still not coming through on R4. Maybe it just take another while. Alright, let's check one more time. There you go, it got some routes from R4 now. It just took time. And then on R3, okay, we got all these BGP sessions. It's already up. So now let's go to R5 and look at its routing table. So R5, which is right down here, you can see the AS path. One noticeable difference is the AS path is in parentheses, and that's signify that it's a part of Confederation. So you can tell these are the route that's coming from 65002, here is 65003, which is R4. And the reason that it inserts the Confederation number to the AS path of the route, because the Confederation relies on the same loop prevention mechanism as eBGP, where it would check for its own Confederation number in the AS path, and it will drop the route if it sees its own numbers or Confederation numbers in there. So these are basically maintained within the autonomous system across the confederations. That's the route passed through it. Okay, the other thing that you want to pay attention to is the next hop right here. As you can see that as the route get passed through different confederation autonomous system, the next hop will never change. Okay, very similar to a route reflector. For example, this route right here that belongs to R6, it still have the R6 loopback 0 as the next hop. Okay, this is exactly why we need to make sure that all of our routers loopback 0 are reachable. Because if you do show IPsef for 6601, what the route is actually doing is to figure out using the IGP, or in this case ISIS routing table, how to get to the next hop, which is R6 loopback. You can see right here that route 6601 is reachable via 192.16.06, and then the next hop is actually R1. Okay. If you remember physical topology, R5 has a point-to-point serial link to both R1 and R2. It's just happened that the path through R1 provides the lowest cost metrics, and that's why R5 choose R1 to get to R6. Now, R5, you're trying to ping 6601, sourcing from loopback 10. That should be working. Okay. Same thing if you jump over to R6 and then do show IP BGP. You can see how some of these AS path gets accumulated as it passes through multiple confederations. Like for example, this one right here that belongs to R4, it passed through the 65001, but it's originated 65003 before it comes around. So it comes down this way and then goes back up. It's just a way that particular route has been learned. And then again, the next hop IP never change. Same thing here, the router R5 loopbacks, that's the next hop of R5 loopback 0. So just do a quick review when the way that the traffic gets routed. For example, from R6 to R5, it's hop by hop basis. When the traffic is originated on the router R6, it's just do the route lookup, and based on the BGP routing table, it will look up the next hop for R5 loopbacks. In this case is R5 loopback 0. So the R6 will look up the internal routing table and figure out what's the best path to get to R5 loopback 0. In this case, there's a 2 equal cost path, one to R3 and one to R4. So let's assume the packet picks R3 for that, then the whole process kind of repeats itself on R3. So it's a hop by hop lookup, and that's why every single router in your topology needs to be participating in the BGP. Okay, and that's because if you leave one of these routers, for example R3, out of the BGP topology and the packet gets routed through it, then we have no idea how to reach the destination. We'll just basically drop the packet or follow a completely different route, like a default route. And the way the route gets routed to the destination is based on the IGP metrics. The BGP session is just provide the information where the next hop of the destination will be, but just because, for example, the route is being learned or preferred from R4, it doesn't mean that the packet would not be routed to R3, just because that the path through R4 has the higher IGP metrics. Okay, so the topology between BGP and the actual unicast routing can be totally independent. Alright, so that should complete our task number 1.